Hello, welcome to this video. This video is to introduce introduce some new piece of equipment that we're using, as well as giving you an intro into exercise 1 and exercise 2 of experiment number 8. So in this experiment for exercise 1 and 2, we have a signal generator, which you are all familiar with, outputting to an anti-aliasing filter, which you may not be familiar with at this point. I'll come back to explaining the anti-aliasing filter in a second. The signal, again, it goes through the anti-aliasing filter and then splits at the output of the filter to be both read by the oscilloscope and also by your data acquisition logger pro unit, which goes to your computer. The anti-aliasing filter, what it does is that it filters out frequencies at a certain set point. That set point is the digital screen up where my thumb is pointing right now. Right now it's set to filter out any frequency above 390 hertz. It's pretty simple to change. If you wanted to change that, you can go ahead and actually change the frequency. You'll see that the enter sign, the enter lights up here. You press enter and it fixates it. So right now it's set to 404, and it's still at 404 until I press the enter button at whatever new frequency I want to set it to. So right now it's set to 390. The filter can be turned on and off in the sense that if I go ahead down to here where it says filter in means that it's actually on. That means it's actually filtering the frequency. Out means that the filter is not working at this point. So now it is not filtering out frequencies above 390. In means it is. These are input gains. This is a sort of a fine adjustment. This is a coarse adjustment. And these gains amplify any signal that comes into the anti-aliasing filter. These signals overload mean that the signal is being overloaded, that it's past the saturation points. As you can tell, as I go ahead and turn down the amplitude of my input signal, you'll see that those lights go off and they go on again depending if I'm starting to hit the overload point or not. Okay, so that's the filter. Exercise 1, you are to set the signal generator to a frequency of 156.25 hertz. You are to set the anti-aliasing filter to 390 hertz. And you are to go over to Logger Pro. Just to start off with, you are to set your sample rate at 1000 hertz for a duration of 0.064 hertz. Go ahead, you do that. Collect your data. Once the data Logger Pro has collected your data, go to File, Export As, Text. Call it Sign 1A and save the text file. I'm not actually going to do that. Go through the exercise. You should have 2 files that you save, Sign 1A and Sign 1B. Once you are done with that, you need to go to Matlab. Now, if you don't have Matlab currently on your computers, you need to get a version of Matlab on it, but I would assume that all of you do. If you go into also on the course website, there should be underneath the experiment handout, there should be a link for you to download 4 Matlab files. These 4 Matlab files are called Import Data, Periodogram, Power Spectrum, and Window. All those are the 4 Matlab files that should be located in a zip file. So unzip them, put them into a designated folder on your computer. Okay, and once they are on your designated folder in your computer, go onto Matlab under Current Folder and set that folder to where those files are located. So again, all 4 Matlab files should be in one folder, and then you need to set the working directory, the working folder for Matlab to that particular file. Because what you're going to do now is that you're going to export those files from Logger Pro, right? You're going to go ahead and you're going to, for example, in exercise 1, you should have 2 files. One's called Sign 1A and the other one's called Assign 1B. You're going to export those, and then you're going to put them all into the same folder as I have here. As you can tell, I have my 4 Matlab files along with all of these text files. All these text files represent the files that you were saving for exercise 1 and exercise 2. So once you do that, I'll go ahead and close this off. In order to run this program, what these Matlab files are doing is running a fast Fourier transform on the data that you collected using LoggerPro. LoggerPro collected the signal from the output of the signal generator through the filter. You're going to go ahead and run the file. You can do it many ways. I choose to right-click on the file. The file that you're going to run is pariedogram. So you go ahead, click on it, run file. It'll come up and it'll say input name of data file. So in this case, I have a file called assign 1a.txt, but I don't fill in a .text. Press enter. The next thing is going to ask you to select a window function. We are not going to be using window functions, so just press none. And after you do that, up come two graphs. The one of interest is the blue graph here, and what it has is on the y-axis is a representative amplitude, and the x-axis are frequencies, and you'll see the spike at the frequencies of which are found in the data file that you just analyzed. So in this case, as you can tell, I set the I set the signal generator to 156.25 hertz. And if you go here, click on data trace, and then click on the spike here, you should see it says 156.3, in this case 156.25. That is the frequency at which we outputted. Okay, so you're going to do that using exercise 1. You're going to look at something called leakage. I'll leave it to you doing the lab to figure out what that is. The point of exercise 1 is to understand what leakage is, and then you'll go through the same exercises, basically setting the signal generator to different frequencies as well as the anti-aliasing filter to different frequencies in order to study some effects of square waves for exercise 2. Okay, so this ends the video, instructional video for exercise 1 and exercise 2 of experiment number 8.